Oftentimes, we are interested in making sure that bodies do not move, such as a building or a bridge. In order to do so, we must satisfy the conditions for equilibrium. The first condition for equilibrium is no acceleration. In other words, the sum of the forces acting on the body have to equal 0. The second one is no torque, and that means the sum of all the torques acting on the body must equal 0 as well. Rigid bodies at rest are said to be in static equilibrium. Center of gravity. In most equilibrium problems, one of the forces acting on the body is its weight. We'll need to be able to calculate the torque on this force. The weight doesn't act on a single point, it is distributed over the entire body, but we can always calculate the torque due to the body's weight by assuming the entire force of gravity is concentrated at a point called the center of gravity. If G has the same value at all points on a body, its center of gravity is identical to its center of mass. Now, while G varies somewhat with elevation, the variation is extremely slight. Finding and using the center of gravity. We can often use symmetry conditions to locate the center of gravity of a body, just like we did to locate the center of mass. The center of gravity of a homogeneous sphere, cube, or rectangular plate is its geometric center. The center of gravity of a right circular cylinder or cone is on its axis of symmetry. Now, when a body is suspended or supported by a single point, the center of gravity is always directly above or below the point of suspension. For example, here we have a coffee cup. It is supported by the top of the handle in the first picture, and we have drawn a line that intersects the center of gravity. Now in the second picture, we have taken it and supported it by the bottom of its handle. So the center of gravity, and we have a line directly below that. The center of gravity is where those two lines intersect.